Hello everyone. This is Rashid Kibria from University of Florida. Today I will demonstrate the efficacy of my developed RTL-FSMx tool on a complex benchmark. This benchmark was analyzed using Intel Quartus Prime, but the control FSM was not detected, and also as a result, the state transition graph, which was very complex, was not extracted as well. In this presentation, I will show you how RTL-FSMx can handle this issue. And the RTL was analyzed perfectly. The control FSM was detected and it was extracted. So I will basically provide you the overview of it. First, you have to find the tool. You can find that inside RTL category. Here you see the RTL-FSMx. You select that and you will get the graphical user interface. The first task, you have to read all the RTL dependency files. For this complex benchmark, it is a complex CPU core, the Z80 core. It has a couple of include files. So we need to first add those dependencies, the RTL dependencies more accurately. So you can find that inside benchmarks. Here, the Z80 folder, and inside dependencies, you will get all the RTL dependency files. And if you select them one after another, and then hit open, it will add all the files to the tool directory. The next task, you have to read all the RTL designs, the main Verilog HDL-based designs, and here we see a lot of files. We'll include one after another. This Z80 core is also an open source RTL core, and it is also shareable. So you can find it and get it from me. And if you click on it and hit open, all the RTL design files will be added. And next, you have to load the tool. So there are two versions. I will first analyze it with V1 version. I hit open and it will add that, and I hit on extract control FSM button. So yeah, you see the process is very fast. It just less than, I would say, 1 second to extract the control FSM, and the state transition graph was extracted using text format. You can find this report here, this FSM underscore FSM.txt, which actually shows you the FSM report. So if you try to analyze this FSM report, the control FSM was inside this design FSM.phi, that is the design name, and it is showing us the clock, the reset signal, which is driving that, and also the other things related to the control FSM. So the state variable, their state encoding length, and also the state encodings and order. And if you look here, there are so many states here because it is a complex CPU core. So it obviously needs to perform a lot of complex operations. That is why there are so many states here. And there are total, from this report, we see there are total 46 states present in the RTL. And the state encoding style which was used is binary. So we have a huge number of unused states or don't care states. And yeah, it is also reporting the FSM input signals and the signals which is controlled by the state variable. Here, now I will show you the state transition graph in text format. So if I click on it and hit open, it will show us. So it is basically showing us the state transition graph in text format. It is presenting us the state transitions, not only those, but also why certain state transition occurred. And here we see a lot of conditions here. And for this state transition, this one is the state transition condition, and similarly it applies for all the other things. And you see all of the state transitions were extracted perfectly by RTL-FSMx. Now I will try to analyze the RTLs with the V2 version of the tool. So I will select that and hit open, And finally, I will click on extract control efficiency button. As I have already mentioned, the V2 version actually uses the Python's graphics library to visualize the extracted STG, and it was heavy, so it takes just a bit time. So you see, it analyzed within 2.89 seconds, and the control FSM was extracted perfectly after being loaded. So here again the FSM extraction report will be the same thing, but mainly we are actually interested to look for the state transition graph in .png file. So if I click on it and hit open, it will show us the state transition graph in graphical format. So here you can clearly see the complex state transitions. We have so many states and so many state transitions. The state transition graph is very complex, and as a result, this STG was not extracted by using Intel's Core Spine. RTL-FSMx is better in this sense because it can analyze very complex RTL designs and also provide you the FSM extraction report within just a few seconds. So what is basically done here, all the RTLs are being compiled first, and then abstract syntax is generated. And RTL-FSMx basically analyzes the generated abstract syntax tree to extract control efficiency from there. And the runtime, what is being mentioned here, it is actually for compiling all the RTL designs plus the FSM extraction process. What I have seen, the runtime overall is just approximately equal to compile all the RTL designs. That means the FSM extraction process, which was the core part, it was very fast. I actually tested it. I saw it. It took only less around 100 milliseconds to extract control efficiency. That is why the runtime of the entire tool is actually dominated by the compilation time for all the RTL designs. That was a quick demonstration of RTL-FSMx for analysis of a complex CPU core, Z80 core. Thanks for hearing.